In this video, I talk about finding values of x. Question 1. The U.S. Marine Corps requires that men have heights between 64 inches and 78 inches. The National Health Survey shows that heights of men are normally distributed with a mean of 69 inches and a standard deviation of 2.8 inches. Find the percentage of men meeting those height requirements. Are too many men denied the opportunity to join the Marines because they are too short or too tall? This first question is asking for the probability that men have heights between 64 inches and 78 inches. First, I need to convert each height to a z-score using the formula z equals x minus the mean divided by the standard deviation. 64 minus 69 is 5, then divide by 2.8 is negative 1.79. 78 minus 69 is 9, divided by 2.8 is 3.21. The probability that z is between negative 1.79 and 3.21 is 0.9993 minus 0.0367, which equals 0.9626. If you are appointed to be the Secretary of Defense and you want to change the height requirement so that only the shortest 2% and tallest 2% of all men are rejected, what are the new minimum and maximum height requirements? The question is not asking for probability, the question is asking for new height requirements. I need to use the following formula. X equals the mean plus the z-score times standard deviation. If the shortest 2% of the population is being excluded, I look up the area 0.02. If 0.02 isn't in the table, I need to use the area closest to 0.02. From the table, the area closest to 0.02 is 0.0202. The z-score corresponding to that area is negative 2.05. Now I enter the values in my formula. X equals 69 minus the 2.05 times 2.8 equals 63.26. If the tallest 2% of the population is being excluded, I look up the area 0.98 in the table or get as close to 0.98 as possible. The area closest to 0.98 is 0.9798. The z-score corresponding to that area is 2.05. X equals 69 plus 2.05 times 2.8. The answer is 74.74. So the new minimum height requirement is 63.26 and the maximum height requirement is 74.74. Okay. Question 2. Assume that a test is designed to measure a person's sense of humor and that scores on the test are normally distributed with a mean of 10 and a standard deviation of 2. Find the score separating the bottom 75% from the top 25%. Again, I'm looking for a score. I need to look up the area closest to 0.75. The area closest to 0.75 in the table is 0.7486. The z-score corresponding to the area is 0.67. X equals 10 plus 0.67 times 2. The answer is 11.34. The score separating the bottom 75% from the top 25% is 11.34. Question 3. Assume that scores on a Calc 1 test are normally distributed with a mean of 65 and a standard deviation of 12. Find the score separating the top 10% from the bottom 90%. I need to look up the area closest to point 90. The area closest to point 90 is 0.8997. The z-score corresponding to the area is 1.28. X equals 65 plus 1.28 times 12. The answer is 80.36. You normally score a whole number on a test, so I would need to round my answer to 81.